Hello, I'm James Helfrich. I'd like to share with you some of the supplementary material which comes with the C++ data structures textbook. With the textbook, of course, you get the text. You also get a collection of YouTube videos which demonstrate various aspects of data structures. You get some unit tests which help you to grade and help the students to implement the data structures. But you also get a collection of slide decks. There's one slide deck for every chapter in the textbook. Let me share with you one of the slide decks so you can get an idea of what you can see. There is one slide deck for every chapter. This is Chapter 6, Binary Search Tree. On the splash screen, you get a schedule and a today's plan, which you can fill in according to the needs of your own specific course. We also have a summary slide to give you a gist of what this data structure is all about. In this case, of course, the binary search tree. I'd like to draw your attention to the menu on top. It says Definition, Implementation, Application, Examples, Exercise, and Problems. These correspond to the various sections in the textbook. Let's take a look at each one of these in turn. At any point in time, I can click on Definition, and it'll take me to the definition page. Then I can click on Implementation, or Application, or Examples, or Exercises, or Problems. In the definition, we have a summary page which describing all the public interfaces associated with, in this case, the binary search tree. And then we have the information about the constructor, assignment, iterator, access, and you can, of course, look at these in any order that you want. But let's take a look at access for an example. So here we have a description of what the access is like, and then we can load a binary tree, find on 7, find on 2, and then find on 10. Well, 10 is not there, so we get the end iterator. And let's take a look at an insert. And now I can walk through and build the binary tree one step at a time, and then the students can see how it works. In each case, I can always jump to a different aspect of the interface and demonstrate how it works and respond to the students' questions. And this is all under the definition section. The implementation section helps students to build, in this case, the binary search tree from scratch. And once again, this mirrors the textbook exactly. We're going to talk about the two implementation options, the 2, 3, 4 tree, and how it relates to a red-black tree. Let's take a look at the 2, 3, 4 tree as an example here. So let's take a look at the 2, 3, 4 tree. So in here we have a 2, 3, 4 tree where the black nodes go between the 2, 3, 4 nodes and the red go in between the nodes. And then we're going to categorize these by bringing them out into a binary tree, and then we have the final red-black tree. Another example, here are the rules for a red-black tree, and then we can go through the different cases for how to implement them. Let's take a look at how we insert into red-black tree to have a further idea how this works. We have several cases where I have no parent, a parent is black, the parent and aunt are red, and the parent is red and the aunt is black or non-existent. And then from there, we have several subcases. So you can imagine bringing up this slide and then having students work through problems and using this as a reference. The next chapter is application. In this case, we only have one application for this chapter, which is the binary sort. And then once again, I can click on that. And then we have the pseudocode algorithm for the binary sort. And maybe we can have the students implement this in C++ if we decide. The next section is examples. And here we have 6 examples. Now, these examples are also presented in the textbook. And so both the problem and the solution is presented. For an example, if you like to demonstrate 2, 3, 4 insertion, then you can have them work through the problem. There's also a large number of exercises. In each case here, the exercise is presented in the textbook, but the solution is not. So you can use this for summative evaluation if you like, or have the students work through them in class like I do. So let's take for an example, we want to do a binary search tree erase. And then I have 3 examples here, and the first one is erase 9, and then we can look at the answer, and then erase 67, and then erase 50, so we have both the problem and the solution. Let's take a look at another exercise. Let's say I want to build a 2, 3, 4 tree. So first I'm going to start with 80, then 70, and then 60, and then 50, which requires me to split, and then 40, and then 30, which once again requires me to split, and then 20, and then 10, which once again requires me to split. So in each case, we have animation demonstrating the solution, and students can follow along as they go. The final section, each slide, is the problems. And the problems are larger labs that usually takes the student several hours to complete. And I usually use these as my summative evaluation. I need to emphasize that at any point in time, I can jump between various sections of the book with just one click. Every slide is just 2 clicks away. One click to get to the summary and one click to get to the specific slide. I've been teaching with these slide decks for several years now. I hope you find them as useful as I do. Thank you.